Hi, I'm Ashley, and in this video we're going to do practice 1, reading and grading to ports. I create a program that reads digital value from port B and adds the constant 4. The number 4 comes from the sum of my students' ID digits, 2 plus 4 plus 5 plus 5 plus 6 is 22, and 2 plus 2 is 4. We add 4 and then choose the results on the left, connect by port D. Let's open the MCC to start the configuration. Here in clock source, we select external clock and we set it 12 million. We're going to select port B from pin 0 to pin 6 as an input, and we also select port D from pin 0 to pin 6 but as an output. We're not going to change the names, but for port B, we select the start high and pull up, and for port D, are just output, so we leave them like that. We're going to generate this and save it. This line includes the MCC library. Here we declare a variable called TNCT and its value is 4. Here's the main function. All the program start running from here. This is the while loop. It means all the core inside will run forever. Here it reads the digital value from pin B and adds the constant. Then sends the result to port D, which shows it on the LEDs. This is the circuit we use for practice ones. In the center we have the ATMEGA328P, and on port D from pin 13 to pin 10 we connect resistors to connect the LED bar graph, and the other side goes to ground. On the right side we connect the dip switch from pin 12 to pin 17, and the other side goes to ground, and we also connect the pin 7 to ground. Now we upload the corresponding file and we can start with the simulation. Here we can see if all the switches are off, the LED number 4 is on, and if I turn on 1, the number 5 is on, and if I turn on another one, number 6 turn on, and it continues like that. Okay, to upload the program, we open Xloader. Here we select our file. Here we select the ATMEGA328 because it's the one we're working with. Here in my case is country, and upload all, and that's all. Okay, here we have our physical circuit. Here we can see our dip switch and the LEDs. This side of the dip switch goes to ground, to the negative side, and another side goes to positive to give a voltage. We connect the LEDs with the cathode to negative, and the resistors goes to the Arduino from port 0 to 6, and the dip switch goes from port 8 to port 13, and on the cathode side, on the negative, we connect ground. Remember that my constant is 4, so here the dip switch is off and we're showing the number 4. If I turn on one of the dip switch, 5 turn on. If I turn on another one, is 6, and it continues like that. I'm gonna turn on all of the dip switch, and here we can see 67. That is the zoom from my deep switch, and it's showed by the LEDs. Hi, I'm Ashley, and in this video we're going to do practice 2. That is basically a binary counter with two buttons, one to increase the value and another to decrease it. First, we're gonna start opening on our MCC to start the configuration. Okay, first, and clock source. Here we select external clock, and we set it 12 million. We're going to select port D from pin 0 to pin 7 as an output, and port B, pin 0 and pin 1 as an input. We're going to change the names. The port B0, well, in my case, I call it button 1, and port B1, I call it the button 2, and we select start high and pull open, and the port D, we left them like that, like output. We're gonna generate this and save it. Okay, let's continue with the code. First, we include the libraries, and we declare this variable called CNT to store the value that increase or decrease. This is the main function. All the program is running from here, and we send the initial value of CNT to port D. Then we open this while loop to check if the buttons were pressed. First, we check if button 1 is pressed, and well, this delay is used for a devotion, and then the counter increase and shows to port D. Here we wait until the button is released, and for button 2 is basically the same, but instead of increasing, it decreases the value of CNT. Okay, here we have our simulation. In the center we have the ATMEGA328P, and on the left side from pin 30 to pin 10 we connect resistor to connect our LED bar graph, and the other side of the LED goes to ground. Here in pin 12 we connect the button 1 to increase and button 30 to decrease. The buttons are connected with resistors to power, and the other side goes to ground. Okay, now we upload our corresponding file, and we can start with the simulation. Here you can see if I press the button 1 to increase, so 1, 2, 3, and if I want to decrease it, I press button 2. Okay. Okay, here you can see our physical circuit. Here we have the LEDs and the buttons, one to increase and another to decrease. We connect the LEDs to the cathode to negative, and the other side the resistor that goes from pin 0 to pin 6. For the buttons, we connect one side to negative, to ground, and another side we connect the resistor. This one that goes inside of the button, we connect to pin 8 or 9, and another one that goes outside of the button, we connect to voltage. And now we can see if we push the increase button is 1, and we can decrease with another button. And that's all. Remember to upload the program. It's on Xloader. Here we select our file, ATMEGA43, and that's all. Hi, I'm Ashley, and in this video we're going to do practice 3. This program shows the number from 0 to 9 on a 7-segment display, and when it reaches 9, it comes back down to 0. It repeats this up and down cycle forever. Okay, so now we're gonna start opening our MCC to start configuration. And here is it. Here in clock source, we select external clock. Here we set it 12 million. We're gonna select port D from pin 0 to pin 6 as an output. We're not gonna check the names. We just select output. Let's generate this and save it. Begins with the code. Here include the libraries. We find a delay time of 300 milliseconds. We declare a variable called CNT. This variable stores the current number to show it starts with 0, and this variable called cambio or direction change as 1. 1 means up and -1 means down. Okay, this function convert a number into a 7-segment display. It depends of the case. It checks which number is from 0 to 9 and returns the correct display code. Here it gives back the value for the display. Okay, let's start with the program. Here, this function shows the correct number of CNT on the 7-segment display. Okay, let's open a while loop. Okay, let's open a while loop. It adds or subtracts 1 from the number depending on the direction. If the number is 9, we start going down with the -1. And if the number is 0, we start going up. And here we're going to show the number on the display. And here we wait before changing the next number. Okay, let's continue with spoiler. Let's continue with the simulation. Here we can see the ATMEGA328P. And well, we select the port D as output. So we connect the resistors from pin 30 to pin 10. That goes to the 7-segment common cathode. The resistors are connecting in order. Here we can see the first one goes to the first one, the second one to the second, and all of that. Well, we select the corresponding file. Here we have, and now we can see the simulation. It's going up and it's going down. It's going down when it's 90. Okay. Okay, here we can see the physical circuit. Here we had a 7-segment display and the bottom. We connect this 7-segment display following this photo. Here we can see the order, and we connect with resistors. All these resistors goes from pin 0 to pin 6, and this one goes to ground. Okay, for the bottom we connect these resistors from this side, and this one that goes outside of the bottom goes to pin 8, and this one that is inside of the button we connect to voltage, and this one on the other side goes to ground too. Okay, let's upload our circuit. Here we can see it's going down and up. Hi, I'm Ashley. In this video, we're going to do practice 4. This form displays my name and my student ID on a 7-segment display. So let's start with the MCC configuration. Okay, here in clock source, we select external clock. Here we set it 12 million. We're going to select port D from pin 0 to pin 6 as an output. We'll leave them like that. Let's generate this and save it. Okay. Okay, let's continue with the code. Here we include the libraries, and this is an array called message with hexadecimal values that represent letters and numbers for a 7-segment display. Okay, this is a counter used to go through the message. It's called CNT. Okay, here we start running the program. We open a while loop, and well, this sends the current value from message to port D to show it on the display. This increments the counter to move to the next character, and if it reaches to the end of the message, the counter resets to 0 to repeat it, and we wait 500 milliseconds before showing the next value. Okay, let's start with the simulation. Here we can see the ATMEGA328P. Okay, we select the port D as an output. So we're going to connect the resistors from pin 30 to pin 10. And to connect to the 7-segment communicator in order, here we can see the first one goes to the first line, the second one to the second, and well, all of that. Now we upload the corresponding file. Let's simulate like that. Okay. Okay, here we had a physical circuit. Here you can see the 7-segment display in the bottom. We connect this 7-segment display following this photo, the order of the letters. Connect with resistors from pin 0 to pin 6. For the button, we connect a resistor here, and this one that goes outside of the button is connected to pin 8, and this one that goes inside of the button we connect to voltage, and this one on the other side goes to ground. So let's upload our file. Here's it, and here we can see my name and my student ID. Hi, I'm Ashley. In this video, we're going to do practice 5. This program simulates two traffic lights. So we're going to start opening our MCC to start the configuration. Here in clock source, we select external clock and we set it to 12 million. We're going to select 4D from pin 0 to pin 5 as an output. And now we're going to change the names from pin 0 to pin 2. It's the first traffic lights, so we need a red LED, a yellow LED, and a green LED. And from pin 3 to pin 5 is the same. Let's generate this and save it. Let's continue with the code. Here we include the libraries. We define the delay of 300 milliseconds, and we declare this variable called E. This is the main function. The program starts running from here. And well, this is the while loop and this is the for loop. This loop goes from 1 to 60 to 26. Okay, this is our first condition. If it is between 1 and 5, do this. The LED red and red 2 and green turn on. This is the other condition. If it is from 6 to 10, do this condition. The LED red 2 turn on and the LED green start blinking, and we wait. Here we wait too. This is the other condition. If it is from 11 to 30, do this combination. The LED yellow turn on and the LED red 2 turn on too. Here we wait. This is the other condition. If it is between 14 and 18, turn on red LED and green LED too. We wait again. This is the other condition. If it's between 19 and 23, green LED green 2 start blinking and LED red turn on. Here we wait. This is the other condition. If it's between 24 and 26, the LED red turn on and the LED yellow 2 turn on too, and we wait 300 milliseconds. This is our code, so let's go to the simulation. Okay, let's continue with the simulation. Here we have the ATMEGA328P, and we select 4D as an output. So we start connecting our LEDs. The first one is the red LED, it goes to pin 30. On pin 31, we're going to put our yellow LED. In pin 32 is a green LED. We continue on pin 1, goes the green LED. Pin 2, the red LED. And pin 9, the green LED. We connect all to ground. And we select our corresponding file. This one. Okay. Okay, here we can see our physical circuit. Here we have the LEDs, and the other side we connect resistors, the cathode to negative, this one to ground, and we connect this this side from pin 0 to pin 2, and these trees from pin 3 to pin 5. So let's see. Remember to blow the flame. Now here we can see it.